Okay, welcome back. We'll continue on with these because I think this is an important part of what we do and will help us in the long run. Okay. All right, so for our purposes here, what we want to consider is the remainder of these trigonometry particular sets. So the product rule, we're going to have y dash equals uv plus vu. Now, u and v are fairly straightforward in that u is simply 2x. However, v is going to require a chain rule. So v is equal to cos 3x. So let's choose another pronumeral, m equals 3x. V can be rewritten in terms of m, so dv dm and dm dx. So this is just to get v dash. Okay, this is just to get v dash. So the differential of sine is cos, so cos is minus sine m, and d dx 3x is 3. So we put these together, so v dash will be equal to minus 3 sine 3x. So that wasn't too bad in the end. But I prefer that you do your working out. If you shortcut this, you will come unstuck. So don't do any shortcuts, please. So y dash is u dash times v plus v dash, or now minus 3 sine 3x u, and u was x squared. So I'm going to put this, just insert the x squared in here. So we'll have 3x squared, and it was sine, wasn't it? So that's our final product rule. It's a minus because of the minus here. So that is u dash v plus v dash u. Okay, that's all that is. Fairly straightforward, but nevertheless, it's embedded chain rules. So embedded chain rules are worth the practice, which is why I'm doing this before the break. All right, so we've got a product rule again, u, v. So u dash is fairly straightforward because it's 1, I'm going straight to the result, the square root of x. X to the half out the front, half minus 1 is minus a half, there it is there. However, v is more difficult because of the square root of x. Okay, so we're going to let m equal x to the half. Therefore, v will be equal to sine m. So dv dm and dm dx will cause us to have v dash. Okay, so the differential of sine is cos, and m was the square root of x. This one is a half, x to the minus a half, which is 1 over 2. So we got that together. So together, they represent v dash. Okay, so y dash will be equal to u dash times v plus b dash times u. So they're a product, so they'll cancel, and you'll be just left with sine root x 2 root x plus cos root x over 2. So that'll be your final answer. Okay, so yes, it's a bit complicated, but it's certainly worth you doing. Okay, so what do we have there? Square root of x, sine square root of x, so square root of x times sine the square root of x sine square root of x, rationalised on the bottom. So so all we need to do is multiply this by root x, and we'd have root x on the top, so we'd have sine. Actually, I might just put that in. So 1 in disguise. For that one, 1 in disguise. So we'll bring this down here. Say y dash is equal to sine root x plus root x cos root x over same family 2 root x. Okay, and I think that's where we ended up. Sine root x plus root x cos root x over 2 root x. So just that finalising of the equations. Alright, so let's have a look at tan root x times x cubed. So this is u, this is b. So v dash in this case is fairly straightforward, 3x squared. U is equal to tan x to the half, requires a chain rule. Let m equal x to the half. So u will be equal to tan m. So we'll have a du dm and a dm dx. Okay, so this is just to get u dash. So u dash will be a product of those. Okay, so tan m is sec squared, and that is a half x to the minus a half. So this becomes sec squared square root of x. This becomes 1 over 2 square root of x. So we put them together as a product, and u dash is equal to sec squared square root of x over 2 root x. Right, so y dash will be equal to u dash v times x3 plus v dash u tan square root of x. So again, I think making 2 root x the same because this is over 1 will allow you to put it in terms of. So that's actually done. I'd be happy with that. but to put the 2 root x on the bottom requires a 2 root x and a 2 root x. So we'll end up with 3 2s are 6x squared root x. And we'll end up with x, so we'll do it this way, x cubed sec squared root x over 2 root x plus 6x squared root x tan root x over 2 root x. We can put them all together then. And it's x3 sec squared x plus 6x squared root x tan root x all over 2 root x. So sometimes they get a bit daunting, don't they? Okay. Alright, so what I'm going to do is I want the emphasis to be on I'm happy with the product rule and the chain rule. I'm going to do these as worked examples. I'm not going to do a video of this because I want to de-emphasize the quotient rule to some extent. But then what I will do is I will do this particular question. Now logarithms I'm going to leave until we come back from the break, so we'll do that afterwards. But I'll just do this one example to finish this video up. Okay, find the equation of the tangent and normal lines to the curve y equals 3x when x equals pi on 18. So we need to find y dash. So y dash will be equal to dy dx. And the problem we've got there is that we've got a chain rule. So we have to let u equal 3x. That means we can write y in terms of u. And then we can say dy to u and du dx. So that's 3. That's the calculus done. Differential sign is cos. And u was 3x. Wow. Put them together and you get y dash is 3 cos 3x. Great. That's the differential. In other words, that's the m of the tangent. It's the same thing. It hasn't lost its meaning. So it wants the equation of the tangent normal lines, so we need to work that out. Now the other thing we want to do is consider y. We've got the x value, so we've got an xy pair. Okay, our x value is pi on 18. So we'd like to know the y. So if we put this in as function notation, we'll get the corresponding y pair, sine 3 lots of pi on 18. Now what we'll notice is that 3 is once, 6, it's pi on 6, sine pi on 6, okay, is the smaller angle has the bigger denominator, so the sine is positive, short, y, half. So the other part is a half. Exact values trick. You see what I did? Exact values trick. Okay? So there are our two values. So we've got enough now to go ahead and work out our tangent. We've got yt is equal to our gradient. Oh, we didn't do the gradient at. So let's do that. Let's do m at pi on 18, which is the same as saying y dash at pi on 18, which is the same as saying dy dt y dx at pi on 18. Are we getting the message now? So what that's going to mean is we're going to put everywhere there's an x, we're going to put pi on 18. 3 cos 3 pi on 18. What does that mean? Exact values tree. Cos, that's going to cancel. And 6 pi on 6. Exact values tree. The smaller angle has the bigger denominator. So this side here is a half. Hypotenuse is 1. And by association, x is equal to root 3 on 2. So cos pi on 6, this bit is root 3 on 2. So multiply that by 3 and we'll get 3 root 3 on 2. You can't do Maths 1 without this. Okay? You need to understand that. So we're going to do our m, y equals mx plus b. So m we just worked out as 3 root 3 on 2, x tangent plus b. Now we've got these x and y values. This is a half. This is 3 root 3. This is pi on 18. This is b. It's the same thing. We're just doing exact values tree. So now you're understanding how important this white sheet was. Because going into just doing this stuff here is assumed knowledge. You've got to go into your next subject, guys, knowing this stuff. Okay? So we need you to labour. We need you to persevere. Now's the time not to lose heart, but to get busy, busy, busy. Okay, it's a big week this week, and I get that, but you've got the fortnight to work it out. All right, so let's see what we can do here. I want to get all of this stuff over here. So we've got a minus 3 root 3 over 2 pi 18. What you do to one side, do to the other. Okay. So we've got a total of a half minus 3 root 3 pi and 2/18 of 36 equals b. So to make that 36, we have to multiply this by 18. 2/18 of 36, 18 on 18. So that's 36. That'll be the same family. So 18 minus 3 root 3 pi over 36 is equal to b. So therefore, yt is equal to 3 root 3 on 2x plus 18 minus 3 root 3 pi over 36. Bit convoluted, yes, but we followed the same procedure. Okay, we followed the same procedure. Okay, so here's where it gets a bit interesting. Algebraic gymnastics. The calculus is not taking us anything. The calculus has got the chain rule in it, but once that's sorted, the rest of it's, wow, the same kind of thing. Okay, so remember this, that m tangent m normal is equal to minus 1. And we've already got one gradient. So we've got 3 root 3 on 2 mn equals negative 1. So times by 2, 3 root 3 mn is equal to minus 2. Divide by 3, divide by 3, root 3, root 3. So therefore mn is minus 2, 3, root 3. Okay, so then we've got to repeat all of this for yn. So yn is equal to minus 2/3 root 3 x n plus b. We're using the same pairs, so half will equal minus 2/3 root 3 times pi on 18 plus b, and we're in search of b because we want to write over here yn minus 2/3 root 3 x, and then whatever b turns out to be. So we're going to add it to both sides, and so we're going to have half and what's 3/18? 54. So we're going to have 2 pi 54 root 3 is equal to b. Now I could leave it as that, but I'm not going to. 54 is 27. So 27 times 2 is 54. So b is 27 plus 2 pi over now that had to be root 3 too. So it's 27 root 3 actually over 54 root 3. That is our normal. So really throwing it all at you now. This is about as hard as it gets. I'll do the paperwork on the quotient rule, and we'll do logarithms next week. But for now, that'll be enough. All right. Have a good break. Thanks very much.